This is a brief introduction to pointers. Every variable that we declare is going to go ahead and reside somewhere in memory. And it's going to go ahead and take a byte, 2 bytes, 4 bytes, depending on the actual type. We can use the size of operator that's available to us to go ahead and find out how big the actual data type is. So for example, I could do a size of and then in here put int, and then I could display that information, and so what comes back to me is the number of bytes. The one thing that we need to keep in mind is that with a pointer variable, it is like any other variable. It's able to go and hold a piece of information, but that piece of information can be only an address. It could also be a 0 or a null. Null and 0, they're one and the same. And this address that we're going to go ahead and put inside of this particular variable is not something that we generate. We have to grab the address from some other place, which we'll talk about in just a bit. And a pointer that contains, of course, a 0 is referred to as a null pointer. And what happens is we are able to go ahead and get a hold of the information in some variable, like an int, directly, or we could actually go ahead and get access to it indirectly through a pointer variable, as we'll come to find out. We have these symbols that we use. We use the ampersand, that is the address of operator, and then the asterisk, that would be the indirection operator. And we'll go ahead and talk about this. One thing that we need to mention is that we could actually go ahead and do all kinds of arithmetic on pointer variables, and the only reason why we could do this is because is with regards to arrays. So if we have arrays, then we're able to go ahead and do pointer arithmetic, as we'll go ahead and talk about that later as well. Now let's go ahead and get into some syntax and find out how this is done. So first and foremost, what is going on here is I've gone ahead and declared this variable int a equals to 5, and so I've declared the variable int a, and then I'm assigning a value 5 to it. I could also go ahead and repeat this statement by breaking it up into a couple of statements. I could actually go and do the declaration and then do the initialization later. When we declare a variable, what happens is we go to some place in memory, and that place, let's just say it's address 1000. I just made up that number. And this 1000, of course, we have no control over. And we're going to go ahead and stick a 5 in that location. So there it is. So when we go ahead and declare a variable, we basically go to an area in memory that we don't have any control over, and we place something in the content area. As you notice, I have a content, I have an address. The only things that we can manipulate with regards to a variable would be the content area. The address, we can only read from it. And you notice that when we go ahead and refer to the actual variable name itself, we go ahead and just get access to the content. So the variable gets access to the content. Let's go ahead and take a look at this notation right here. So cout, then a, this is going to go ahead and display whatever's sitting in the content area. If I go ahead and use the ampersand, prefixing the variable, then that's going to go ahead and display the address. So cout ampersand a is going to go ahead and display 1000, which of course would be the address of where this content is sitting at. Okay, so this is the normal variables that we have dealt with. Now let's go ahead and move on to a pointer variable. So here we're declaring a variable b that is able to go ahead and hold the address of an int. So once again, b is able to go ahead and hold the address of an int. Now, exactly where do we go ahead and get an address of an int? Well, we can't just generate an address. We have to go ahead and find an int. Well, there it is. A is an int. There it is. And then, of course, this a, which is an int, it's got an address, which is that 1000. Now, how do we get access to that 1000? Well, if that's a, ampersand a gets us access to that 1000, and this is what we have. We go ahead and take that 1000, and we go ahead and assign it to b. Let's go ahead and take a look at this. We're able to go ahead and take this notation right here, the first line, and break it up into a couple lines. We declare the variable, which gives us this area in memory, and then we go ahead and do the assignment, b equals to ampersand a, which means that b, once again, whenever we go ahead and make a reference to the name of a variable, we are referring to its content area. And so b, this location right here, is going to go ahead and contain this address right there, which is the address of a. Now, in having done so, at this point now we have created a link between these two variables, which means that now we're able to go and get access to the contents of the variable a, either directly through a, or we can get access to it indirectly through b. You also will notice that what we have here is a unidirectional relationship, and that through B we're able to go ahead and get access to A, but through A we cannot get access to B. And the reason for this is because inside of B, in this content area, it says, why don't you go ahead and jump on over to location 1000. So there it is. And of course, once we get to location 1000, we can get a hold of its content. But we can't do it the other way around, because when you look over here, there is nothing that actually tells us about location 2000, which is where B is sitting at. So that's why it is unidirectional. Let's go ahead and take a look at some syntax here. If I was to go ahead and type in cout B, once again, the name of the variable would give me access to the actual contents itself, which is the 1000. If I was to go ahead and put in ampersand B would give me the actual location of where we're actually storing the content, which in this example would be 2000. Now, what about this one right here, cout asterisk B? Now, this notation is kind of interesting, and I think the best way to go ahead and find out what to do with this is to go ahead and just go over this notation one character at a time. So I'm going to go ahead and start with B. What is inside of B? Inside of B we have 1000, so that is a location, okay? And then we go on, move on to asterisk. So at this point we're going to go and ask the question, well, what are the contents of this location 1000? So B is location 1000. Asterisk says give me the location of what is sitting, or give me the contents of what is sitting in location 1000. So let me go jump on over to location 1000, and its content is 5. Now, we could, of course, go ahead and display the contents, as we have done in this case, or we could actually go ahead and modify it. So in this case, once again, B, which is the 1000, asterisk says, why don't you go ahead and move on over to the content area of location 1000. So location 1000, its content area. Now I'm sitting in this location right here, and this thing says, why don't you go ahead and modify it and make it a 20. So this is something that we could do with this pointer variable, either directly get access to that 5 or indirectly. You also notice something else that we have done here, which is B equals to ampersand D. D is another integer variable. So here we have D equals to 5, so there it is, D, and there's a 5 in there, and it's sitting in its own memory slot. And what I've decided to do is, instead of actually taking B and assigning to it the 1000, I'm saying, why don't you go ahead and put inside of this location right here the address of D. So D, its address is 4000, and so the net effect of this statement would be to go ahead and take that 4000 and stick it right in here. And in having done so, now I no longer have a link from B to A, but rather I would actually have a link from B to D, because of this notation right here, which says, once again, take the address 4000 and stick it in B, and B is right there. One thing that I need to mention here is that if we were to go ahead and take a look at this notation right here, this is a common mistake that's made. So when we go ahead and do int asterisk B, notice that all of this is connected together. This is all one declaration. When we're doing the assignment in this statement right here, we're actually taking the B and assigning it to ampersand A. We're not taking the asterisk B. Okay, so it's just the B by itself that is being assigned to ampersand A, which means that we want to go ahead and put something right there, which is where B is. And in this case, we're putting in the 1000, which, of course, would explain why this notation right here can be broken up into these two statements, and the reason why it looks the way it does. Int asterisk B, and then B equals to ampersand A, and then there it is, B equals to ampersand A. Finally, let's just experiment with another pointer notation here. And you notice this one actually has a couple of asterisks. So what we're doing is we're saying variable C, which is this variable right here, which has its own address, 3000. We want to go ahead and put inside of here ampersand B. So there is B, there's ampersand B, which is the 2000, so I'm sticking the 2000 in here. Now, what is going on here, this means that I can actually go from here to over here, because this is telling me you can jump on over to location 2000, and then when I'm here, I can go ahead and jump on over to location 1000. Notice the number of jumps that I need to make to get access to that final primitive data type. I can jump from here to here, and then I can jump from here to here, and that's it. I can no longer do any more jumps, which explains why we have the two asterisks. So the two asterisks are telling us, well, what are the maximum number of jumps that I need to go ahead and do to get access to that final int? So 1, 2, and that gets me access to that int. In this case, notice, I just go ahead and do one jump to get access to an int. In this case, I don't do any jumps because the int is already available to me. Once again, this notation could be actually broken up into the following, which is just the int asterisk asterisk c, and then finally we just go ahead and assign this area right here to the address of b, which is that 2000. So just make sure that you understand that these two notations are exactly the same, and that it's really the c that is being assigned to the address of b, because we are wanting to go ahead and be right there. Now, with this particular notation, there are all these options that are now available to us. If I were to go ahead and do a cout c, that's going to go ahead and display the 2000. If I do a cout asterisk c, so let's go ahead and take a look at this. C by itself is 2000. This asterisk c says, well, tell me the contents of what is sitting in location 2000. So location 2000, let's go over here. Let's look at its content, and so I get the 1000, which explains why we have this. In this other scenario, I have C, which is 2000. Then I go ahead and say, all right, tell me the contents of what is sitting in location 2000. So location 2000, its content is 1000. So now I'm sitting right there. And so this final asterisk says, tell me the contents of what is sitting in location 1000. Location 1000. There it is, its content is 5, which is why we have the 5. Now, of course, if we want, we could actually go ahead and modify the 5 to become a 20, as we have done right there. So we can display it, or we could actually go ahead and modify it. Now, also, we could not only modify this, but we could also go ahead and modify this area right here. So if I were to go ahead and just take C, which is 2000, and then this other asterisk says, why don't you go ahead and jump on over to location 2000 and take a look at its contents. So now I'm sitting in this box. I'm sitting in a content box. And now I want to go ahead and modify this to go ahead and contain, instead of the 1000, this 4000. And of course, this 4000 is address of D. So the address of D is going to be placed right there. So the address of D is being placed right in here. Once again, I can actually go and assign it directly to B, as I've done here, or I can actually stay here, do a jump, which is what that asterisk is, and then go ahead and display it. So all of those are available to me. Now, there are a couple of things that I just want to go ahead and end this video with, which is we need to make sure that the content area is storing whatever you're telling it. So if you're saying that it's going to go ahead and store an int, you put an int. If you're saying that I need to go ahead and do a one jump and then get access to an int, this means that you can only go ahead and store a one jump address. So that would be the 1000 or the 4000, which would then land you on an int. We need to make sure that we're not, putting, let's say, the address of a float, because this thing says you can do a jump that gets you to an int. If I go ahead and put the address of a float, that would be incompatible. So both the number of jumps and also the actual data type at the end that we're getting access to must match. Here's another example. Here it says that you need to go ahead and do two jumps, one jump, two jumps, to finally get access to an int. If instead of two jumps, I go ahead and make one jump, that is, if I were to go ahead and replace that 2000, for example, with 1000, if I were to go ahead and put a 1000, this would mean that from here, I would only need to go ahead and do a single jump to get access to an int, and that would be incompatible. So the number of jumps must match up, and also the data type, which means that after we have done the jumps, what are we getting access to? Int. That must match up. If it doesn't, then we're going to go ahead and get a syntax error. So those are some things to watch out for.